Hi, everybody. Sorry, I'm running a few minutes late. I was having some trouble with Zoom. It wasn't launching for me, so I think we can go ahead and get started. I think you saw about 5 or 6 of me in the room at one time. That's why, because it wasn't working for me. So let me go ahead and get logged into Canvas, and we'll get started. Yeah. All right. I think I'm back on track now. Thanks for your patience. And one of you unmute and just let me know if you've seen the screen that I'm sharing. Anybody? Can you see the screen?
I don't
says
see anything.
started screen sharing, but I can't see nothing.
Say again?
It says you started screen sharing, but I can't see nothing. I don't know if it's like that for the other guy.
Yeah, it's just a black screen that says you started screen sharing.
Okay, let me do it. Okay, and share. Anything now?
No, it's still the same.
Okay, let you guys just stay put. I'm gonna go out and come back in.
Yes, ma'am.
Okay, so now let me try it again. Maybe the second time's the charm here.
Mine finally loaded after 7 minutes.
Yeah, I was having some trouble too. Just bear with me for a second, because it's kind of being finicky today, and it doesn't normally do that. Zoom's pretty reliable for the most part. Okay, can you see it now?
Yes, ma'am.
Oh, thank you. Okay, good. All right. So I'm recording this as always, and I will post the recording for you. The video from last Wednesday is out there. And I will make sure in the next day or so that the video from today gets posted. I just have to send it out for captioning first. Once that happens, I can share it here in the announcements, okay? So let me go into the weekly overviews for today. I'll do the kinematics overview first, and then we'll do the uniform circular motion overview. Okay. So this kinematics overview deals with motion. And so in lecture class, we talked about, the various kinds of things that we can measure, or the various ways we can describe a moving object. And a kinematic description looks at properties like position, velocity, acceleration, distance, displacement, speed, time. And in lecture class, we looked at, you could use formulas. We looked at the equations of motion for an object moving with constant acceleration horizontally, and free fall, which is constant acceleration vertically. And we also looked at graphs as a way to analyze motion or describe the moving object. And so what we're going to be doing in this particular kinematics experiment and laboratory is to look at the relationship between the equations that describe motion and the graphs which describe motion. That's the main idea here, okay? And so that's what all of these objectives relate to. Of course, you have some activities to complete by this Saturday. So we'll take a look at the experiment in just one moment. We'll talk about the post lab and what you need to do for that. And we'll take a look at the lab report for kinematics and what you need to do for that. Those items need to be completed by this Saturday. And to help you with that, I put the chapter from the textbook that we use in lecture class here in the readings. So if you want to go back and take a look at that information, you can do that. And I also shared a series of videos that relate to 1D motion that you can utilize. Okay, so what we want to do first is take a look at the experiment. Then we'll talk about the lab report and then the post lab. All right. So in this particular experiment, you're going to do what's called the moving man simulation. Okay. And so to get to this simulator, I've given you a set of steps. So I'm going to do it. I'm going to walk through the steps to get to that simulator. Normally, I just give you the website, but I put the steps there, which will get you there just the same. So I'm going to open up this other browser, and I'm going to go out to PhET. Okay, and so I'm going to go into, as it tells you in the experiment handout, to click on PhET, then click on simulations, then physics, then motion, then choose the moving man. Okay, so simulations, physics, and I want to, when you come in, and I didn't add this step in the handout, but unclick the HTML5. So don't choose that option. And then you want motion only. So I will uncheck all of these other areas and just keep motion checked. And then you just scroll down. They're arranged in alphabetical order. And this one is the moving man. So you have to go down to the T's, right? Some students couldn't find it because they were looking for moving man and they forgot the in front of it. So now when you come out here, this looks a little bit different than the way you've entered simulations before, because normally you either click the red 5 or you just click the start, or even the simulation opens right up for you. But this time you're going to have to click on the tag that says browser compatible version. Okay. All right. So if you click on that, no, well, I got to click on it right, just the right way. Okay. So click the little arrow in the middle and it launches in the browser. It is not an HTML5 simulator, but what they have done behind the scenes is, for lack of a better expression, rig it so that it automatically opens up in the browser. Okay. So the way you get to it, again, is to go out to PhET, then you're looking in the physics category. You want to make sure that only the motion simulations are checked, and you want to make sure that HTML5 is unchecked. That's a default. Anytime you go in there and search for their simulations, they automatically put HTML5 up because that's pretty much what people are using these days. But I want you to use this browser compatible version of the simulator. Okay. Any questions about that? All right. So when you come out to this website, what you want to do is, just play around with it, see how you can adjust the position and, velocity, and then, in acceleration, you can just type in a number here, you see, okay. And then you can click play and you see he moves around, and pause it. You can, just do the playback for the values that you set. You can reset all of them. you see, and then, okay. So just get comfortable with how you arrange the moving man. The other thing is that what you can look at is, okay, if I give him some values, I'm just playing around with it here. All right. And I'll give it like, I won't give him any acceleration. Okay. Just playing around with it. And I'll start it. And then what you can see is that as it plays with the values that you put in, it creates the graphs for you. Okay. And so you see, I didn't give him any acceleration. So he just keeps the same velocity all the time, but his position is, you know, staying at 0. I didn't allow him to accelerate or anything like that. So he just you know, move with a constant, he maintained his position and his velocity. Okay. And if you want to go back and look at where you put in the numbers, you know, you can do that there. Okay. So play around with the controls first and get comfortable with the simulation, the simulator, and all of its features. And then you can go back into the experiment handout and follow the settings that it asks you to deal with. Okay. So then once you familiarize yourself with the controls, then you go in and complete the various sections that you're being asked for. Okay. And when it says plot your stuff in the graphs below, it's okay for you to do that here. I know, you know, we had the discussion about doing proper graphs and using graph paper, but for the sake of this experiment, you can plot it right there, and that's fine, fine for me. Okay. And then, you know, just answer whatever questions. So at each stage, you're gonna set it up how it asks you to, answer any questions you're asked for, complete any charts, do any graphs, and then answer these questions. Okay. So basically, you're going to use the simulator to complete the experiment handout. Do all of you follow that?
Yes, ma'am.
Okay. All right. Let's talk about what goes in the lab report. So you're going to use this template to write your lab report. Okay. Now, this will be the first time that you're using a simulator to complete the experiment, but then you're using this template to write your lab report. So don't forget, after you've completed the experiment handout, you need to make sure that you write a full lab report. So I'm telling you what goes in the report right here. There's the title, kinematics, put your name, and then the abstract. You're gonna answer the questions, those 4 questions. So what you did, explain the procedure that you followed, okay? How you did it. Make sure that you give the website or the URL for the simulator, because that is your equipment this time, okay? And what you did, excuse me, why you did it, what was the whole purpose, okay? And then what you found. Now, under this one, because you're doing an experiment where you don't have any percent error, you're using the simulator, so you won't have any percent error. But it asks you here, you see it says, discuss the quality of your data based on the size of percent error values, if you have any, and that's where you come in here, discuss something that you figured out about how the values in your data change as you manipulate the simulator. So during this experiment, you're going to be completing tables, you're going to be making graphs. So use them to help you answer that question under what you found, okay? As you increase the velocity or decrease the acceleration or change the position, tell me something that you figured out about you know, the outcome based on manipulating the simulator. Okay. So this one is not about percent error, but you do have to talk to me about something that you figured out. When I'm asking that, I'm asking you for specifics based on the data. As I change the position, the velocity gets smaller. As I change the acceleration, the velocity gets whatever, okay? That's what I'm talking about there, okay? So tell me what procedure you followed, what website you use, why you did all this stuff in the first place, and then something that you figured out about how things change as you manipulate the simulator. Your data and analysis is the completed experiment handout. So you go out to the simulator, you complete the experiment handout, that is your data and analysis that goes in with the lab report. Okay. And then your conclusion. Tell me something that you learned. Okay. Tell me a concept, a formula, or don't tell me I learned how to use the simulator. Okay. That's a given that you will know how to use the simulator. But tell me, if this whole experiment is about kinematics, tell me something that you learned about kinematics that you didn't know when you started. Do not tell me, as I changed the values in the simulator, this happened. That goes in the abstract. In the conclusion, I want to know something in general that you learned about kinematics. Okay? Do you understand what you have to write in the lab report?
Yes, ma'am.
Okay. While you're working on this particular experiment and lab report, if you have questions, please don't hesitate to reach out to me. Okay. And then the other thing that you have to complete besides the experiment, besides the lab report, is the post lab. So for this post lab, what you will do is you will come out here and answer these 5 questions. And then it tells you right here, be sure to comment on at least 2 of your classmates' postings. Okay. So you answer the 5 first, and then you have a debate, a discussion with your classmates about these 5 questions. All right. So that is what you have to do for this week, dealing with kinematics. Do any of you have any questions about anything that you have to do for this particular experiment, lab report, or post lab? Okay. Just as a reminder, the instructions for submitting the lab report are right there in the weekly overview, right there. And then if you have a question, you can add it to the class questions form, or you can email me or come for office hours, whatever is convenient for you. All right. So that's the first overview that you have to complete this week. The next overview is uniform circular motion. Okay. So when we talked about kinematics, we talked about 1D kinematics, which is like the moving man. And we talked about 2D kinematics, where we looked at projectiles and we looked at circular motion. If you're in the lecture class, problem set number 5 deals with projectiles. So I wanted to do something that dealt with circular motion for the lab class, okay? So that's these objectives relate to the kinematics surrounding an object that's moving in a circle with a constant speed, okay? So that's the goal here. And so these are the activities that you'll have to complete for this overview. We'll look at the uniform circular motion experiment. We'll look at what you put in the lab report. We'll talk about the post lab. And then you have some items that you can read to help you either refresh yourself or refamiliarize yourself with this, because we covered this topic in lecture. So I've given you access to the chapter in the textbook that we use in lecture, as well as a series of videos to help with this topic. Right? So any questions about where we're going with this? By now, you should start to see a pattern. Each week, you complete an experiment, you write a lab report, you do a post lab. Every week, that's how it goes. Okay, and in some weeks you have more than one, but that's the general idea. Okay, all right, so let's take a look at this experiment. Okay, so this experiment handout deals with motion in 2 dimensions. In particular, we're looking at uniform circular motion. And when you click this link, it opens the simulator. I know it says click the big red 5. If I'm not mistaken, let's see here. Right. They have gone back and modified their simulators a bit. So my instructions on clicking the big red 5 are kind of like, that's the way it worked last semester. And I did not recognize that they had made an adjustment so that it opens right up. And all you have to do is click this play button, okay? So if you click this play button, then it opens up, and I tell you in the handout to use the model setting, okay? So we're gonna go to the simulator and we're using this model setting, okay? And then you should play around with it. I'm gonna turn on all the bells and whistles, okay? And then I like satellites. Those of you who had me for lecture know we talked about the International Space Station. And I like this simulator because it deals with orbit motion, and they're using orbit motion as an example of uniform circular motion. I might have even opened this simulator during lecture when we talked about orbit, when we talked about circular motion. So once you've clicked on all the bells and whistles and you've set it to where you want it to be, then you hit play and off it goes, okay? And it tells you. Now, the one thing you do need to understand is they're using the blue arrow to say force, but since we don't talk about force right now, that blue arrow for you is actually the centripetal acceleration. Centripetal acceleration. Remember, an object moving in a circle automatically gets accelerated toward the center of the circular path. And that acceleration is called centripetal acceleration. So this object that is going in a circle with a constant speed is accelerating toward the center of the Earth because the velocity is changing. How do I know the velocity is changing? Because even though the speed is constant, the direction, the green arrow, is always pointing in a different direction. And that change in direction is what allows the satellite to have this center-seeking centripetal acceleration, okay? So you can use any setup that you like here, you know, like you don't have to use the satellite. Maybe you want to use the sun and the earth, okay? And see, there you go, okay? You could explore what happens if you turn gravity off, back on, all kinds of things, right? So play around with the simulator, get comfortable with it, and then you're going to use that simulator to answer these 5 questions, okay? That's your experiment for uniform circular motion. Any questions about the simulator or the experiment that you have to do? Oh, hi, Connor. I just saw your chat. I do apologize. I didn't see it earlier. You don't have to worry about calling roll. I'm recording this, so I know who's here and who's not. I have access to the roster of who was available. Okay. And you know, while you mention that, that's a good point that you mentioned. I know that's probably, you know, something that a lot of your other instructors do. They note who was available and who attended. While I notice who attends. If you looked at the way I grade, I'm not penalizing anybody for participating or not. I tell students, it's your money. If you come, I'm going to teach whether I have 1 student or 100 students. So, you know, that's how it goes. I mean, if I don't have any students, then I don't do anything. I just post a notice saying nobody showed up. But if I have 1 student or 100, I'm going to go over the same information. So you being here is for your benefit, because you get to hear me explain this stuff, and you get to ask questions right on the spot to make sure you understand it. Okay, but I'm glad that you posted that in the chat, because that gave me a chance to explain that. Okay. All right, so that's the experiment, that's the simulator. Let's talk about the lab report. So this template looks the same just as the one you use for kinematics. This is the same template that you use for all of your experiments. So the title, your name, the abstract where you answer those 4 questions, what you did, tell me what procedure you followed, how you did it, tell me the simulator website. Because remember, you are writing this for somebody who has no clue. If you don't tell them what website you use, how will they know? Okay. Do not write lab reports to me. I am only the grader. Write them for somebody who is not familiar with this class. That way, you have to give them details, right? So if you want them to be able to repeat your experiment, you have to tell them exactly what you did. What procedure did you follow, step by step? You have to tell them what website you went to. And you have to explain to them why you were doing this experiment, right? And then you have to tell them something that you figured out as you manipulated the simulator, okay? And then your data and analysis, again, is the completed experiment handout. And then in your conclusion, tell me something that you learned about circular motion that you didn't know when you started this experiment, okay? So any questions about the experiment, the simulator, or the lab report that you have to write? Okay. All right. So the other thing that you have to do for this topic, just like for every topic, is to complete a discussion. So you have to answer these questions, and then you have to comment on 2 of your classmates' postings. And remember, you're trying to have an honest dialogue, right? You know, maybe you're working on something and, hey, you know, the way you calculated is different from what they did, or you got some different units from what they did, and you want to talk about it. You know, you want to have a discussion. Just like if you were in a classroom working in a group, right? If I had 20 students in the classroom and I broke them down in 5 groups of 4, that group would answer, each group would answer these questions, and they would work together to do it. And then each person would turn in their work. So that's why you have to answer the questions for yourself. And then you have to have an honest conversation with your classmates about what they posted, okay? All right, the answers like, hey, we got the same thing, or I like your answer, or I agree with you, without any explanation why, is, you know, is not a real discussion, okay? Any questions about anything that you have on your plate for this class for this week? Gosh, we're already in week 6.
Yeah, I got one.
Yes, sir. Go right ahead.
For that first experiment, can I print out those papers and like answer it on that paper and then take a picture and email it to you?
You mean the experiment handout? Is that what you're referring to?
Yes, ma'am.
This handout?
Yes, ma'am, that one.
Yes, please.
Okay.
Yeah, that's why I said the completed handout. Now, some people, you know, I don't have an issue. Some people want to use the handout as a guide and they write their answers out on paper. I'm fine with that too.
Okay,
You know,
thank you.
I try not to make things like, like to be too ridiculous with things. The one thing I do care about is that if you're doing a formal graph, you do it using graph paper, but this experiment is not really like a full-blown graph. It's just kind of like almost like a sketch. So, I'm fine with if you do it on the handout or on paper. As long as you get it to me, we're good.
Okay.
Anybody else? Please ask your question. All right. So the other thing that I want to remind you of is that, you're still supposed to be actively working on the project. And so if you click on activities and assignments on the left menu, there's a link to the project. If you have not started the project, please go and get started, especially if you are in lecture and lab. You want to make sure that you get started early, because I know the tendency is to say, well, it's not even the 1st of October. I got until the 23rd. I'll wait. Please don't do that. Please get started in finding an article for the project, because 9 times out of 10, it's going to take you more than one attempt to find an article that you can use for this project based on the information in the project details. The project details explain what you're looking for and how you find it, which is what you need to be focusing on between now and the 23rd of October. Okay, so don't wait until the last minute. Go ahead and get started. Okay. All right, so with that, I'll stop the share and ask, are there any additional questions? All right, so with that, I will say, I really do appreciate y'all taking the time to join in tonight. The video will be available in a day or so. If you need it, it'll be available in the announcements. Other than that, y'all have a good evening.
You too. Thank you.
All right. We're done, Connor, unless you have a question for me.